Right. Now let us see what is this alarm system example. First, understand the problem domain. What is asked in the problem? Then we will see how to solve this problem. So here, this is a problem statement given to you. Your house has an alarm system against burglary, and you are living in a seismically active area. That means sometimes you will get earthquake also. Okay. And the alarm detects burglary, but sometimes it responds to minor earthquake. It means that if I get an alarm, I can't say that there is a burglary with 100% surety, because sometimes there may be earthquake. The alarm will respond to that and it will ring that. So with the alarm only, I cannot say that there is a burglary. But my problem statement is I have to detect burglary. Let us see how to proceed with the remaining statement. And you have two neighbors. The neighbors are Mary and John. And these two neighbors, they don't know each other. Okay. They are your neighbors, but they don't have any communication among themselves. And if they hear the alarm from your house, they will call you and they will say that there is an alarm. That means that you will come to a conclusion that there may be a burglary. Okay. And it is not always guaranteed. Sometimes there may be an alarm, but these people will not call you and they will not inform about the burglary. Under what condition they will not call you? That is also given here. John always calls when he hears the alarm, but sometimes he will consider the telephone ringing as an alarm and he will call you. That means that when John calls you, there are two possibilities. One is there is an alarm, so he is calling you, or otherwise there is a telephone ringing. He misunderstood that as an alarm and he is calling you. Similarly, Mary likes loud music, so she may be hearing some music with a loud noise. So in that case, there may be alarm from your house, but she will not hear that, she will miss the alarm. Okay. So she will not be able to convey that to you, even though there is a burglary. Okay. So Mary likes loud music and she misses the alarm sometimes. So these are all the different conditions given to us. Now we want to represent the probability distribution of various events by means of the Bayesian network. First, we have to understand what are the nodes we are going to represent in this. There is a random variable, you represent that as a node. So here there is a random variable called burglary, and also there is a random variable called earthquake. Okay. And when there is a burglary, there will be an alarm. When there is an earthquake, then also there will be an alarm. So what you have to do is, the alarm now depends upon two things. One is burglary, another is earthquake. Therefore, these two should be drawn as parent node for the node alarm. Right. Now, definitely both should be drawn. You cannot leave any one, because alarm depends upon both these things, burglary as well as earthquake. Then when there is an alarm, what is going to happen? There is a probability that John is going to call you. When John will call you? John will call you when there is an alarm. So alarm is a parent node for John calls. Then Mary will also call you according to the given scenario. So Mary calls you when there is an alarm. Therefore, alarm is a parent node for Mary. And from John calls and Mary calls, we don't have any other relationship. So this is the graphical representation of our alarm system, where we are representing the entire scenario by means of a directed acyclic graph. If you see this graph, all the nodes will have, all the edges will have a direction, and there will not be any cycle in this. So this is how first you have to draw the graph. The graph will not be given to you. You have to understand the scenario. You should identify first what are the variables we have in this scenario and what is the dependency among the variables. Then you represent them as a graph. Let's understand the probabilities now. The first one, PB. PB is nothing but probability of getting burglary, and PE represents probability of earthquake. Okay, and it is given that PB is 0.001. So what is the meaning is, there is a probability that there will be a burglary in your home with the probability value as 0.001. It means that 0.9999 times you will not have any burglary in your home. Okay, 0.001 times there is a burglary. And what does this table indicates? There is a probability of, you can say that with the probability value of 0.002, there will be an earthquake in your area of your home. Okay, so that is the meaning of this. And these two probabilities, they do not depend upon any other random variable in our scenario. There are totally 5 random variables. These two are not depending upon any other random variable. So we have the straight probability for these events. Now let us consider the next event, alarm. If you consider this, alarm is having two parents. One is burglary, another is earthquake. Therefore, the value of alarm will depend upon the value of these two variables. And these two are binary variables, and we have two variables. Therefore, for this alarm, we should have a table with 4 entries. So what are those 4 entries? So now the first entry is giving the information that there is a probability of 0.95 of getting alarm when there is a burglary and there is an earthquake. And the secondary entry conveys that there is a probability of getting an alarm with value 0.94, given that there is a burglary but there is no earthquake. This is false. That means that there is no earthquake. And the third statement is going to tell that the probability of getting alarm is 0.29, given there is no burglary but there is an earthquake. That means that even though there is no burglary, we are getting alarm because of the earthquake, and that probability is 0.29. But the last entry is also important here. You can consider in this, there is no burglary, no earthquake. In that also you are getting an alarm, but the probability is very, very less, 0.001. So now this is a probability and this is a conditional probability. Because of that only it is written as probability of alarm given B comma E. And now let us see this John calls. When John calls, if you consider this diagram, the probability of John calling, it depends upon the alarm only. It does not depend upon burglary, earthquake, because we have the knowledge of alarm directly. So John calls only based upon the alarm. So we will say that probability of John calls depends only upon the alarm. So probability of J conditionally depend upon the value of A only. And here A will take either true or false. So if alarm is true, that is alarm is ringing and John is calling you, that probability is 0.9. And the remaining probability is nothing but alarm is not ringing, alarm is false, but John is still calling you. How it is possible? So here, sometimes John will consider telephone ringing as an alarm and calls you. Okay, even though there is not an alarm, sometimes he will misunderstand the telephone ringing as an alarm and he will call you. Because of that only we will have alarm is false, but still John is calling you. That probability is given in this. Similarly, the event Mary calls depends only upon the alarm. Mary will call you when there is an alarm. Okay, that probability is 0.7. And sometimes she will call you when there is no alarm also. The alarm is false and she is still calling you. That probability is given as 0.01. Under what case this will happen? Because she may want to talk something to you and she may call you. Okay, so that is this probability. So what is the probability that alarm rings, but neither the burglary nor an earthquake has occurred, and both John and Mary call you? So you should understand all the terms here. What are the things they have given? For all the 5 attributes, they have given the state. Alarm rings. That means this alarm is true now. But neither a burglary nor an earthquake has occurred. So what is burglary? It is false. And what is earthquake? That is also false. That is given by this statement only. Then consider about John and Mary calls you. But both John and Mary call you. That means that John calls is true, Mary calls is also true. Now we found what are the value of different variables. Probability of John calls and Mary calls. Whatever is in this statement, I am writing this as a probability with the conjunctions. Because here it is given that John is calling you and Mary is also calling you, and there is an alarm and there is no burglary and there is no earthquake. So this is a statement given here. So represent everything. Now, how to find this particular probability? For this only, you have to see what is the dependency among various attributes. So now let us consider the attribute John calls. Okay, let us consider the first attribute John calls. John calls depends upon what? John is calling only based upon the alarm. Okay, so I will now write probability of John calls when there is an alarm, because I need to consider the probability that he is calling me only. He is not calling. That probability I'm not going to consider. So I have to consider the probability of John calls me when there is an alarm. Okay. And what about the second one? Mary calls you. So what is the probability that Mary calls me when there is an alarm? And why I have multiply symbol between these two? The reason is these events are not dependent. Okay. I am considering the joint probability. Okay, so when I consider the joint probability, I'll multiply everything. That is the thing we have seen in the previous slide. So here I have to multiply these two. Now let me come to this third attribute, alarm. When you will get an alarm, we will get an alarm based upon two things. Now, see the input to alarm, it depends upon burglary state as well as earthquake state. So you have to now consider what is the probability of an alarm given there is no burglary, no earthquake. Okay, consider only these two values for burglary and earthquake. You should not consider the remaining values because in the statement it is clearly given that there is no burglary, no earthquake. So you consider what is the probability of getting an alarm given no burglary, no earthquake. And then the third attribute is over. Now see the fourth attribute is saying that probability of no earthquake. Okay, so here, sorry, no burglary. Here you see this table. For burglary, I have only one probability. Probability of burglary is given. What is the probability of no burglary? You know that total probability of any event will be one only. So if the probability of burglary is given, you can find the probability of no burglary by subtracting this from 1. So I will have 1 minus 0.001, that is nothing but 0.999. This is the probability. Even though it is not directly given in the table, you can calculate by means of the total probability formula. Similarly, next I have to consider this term. It's nothing but probability of no earthquake. These two values does not depend upon any other thing. So directly we are writing the values here. Otherwise, we will have this conditional dependency also. But we don't have any conditional dependency here. What is the probability of not having earthquake? Here it is given that probability of earthquake is 0.002. Therefore, probability of not having earthquake is 1 minus 0.002. It is nothing but 0.998. Now, let us see the remaining values. Last two we have seen. Let us see the first three values. How to write these values from the table. The first value is probability of John calls when there is an alarm. So go to the John calls table. Here, given alarm. That means that you have to see when alarm is equal to what is the value. Okay, when alarm is true, the probability of John calling when there is an alarm is 0.9. So the first value is 0.9. Then coming to the second, it is probability of Mary calls you when there is an alarm. So go to the table of Mary, conditional probability table of Mary. So here probability of Mary calls you. That means that this true you have to consider. When there is an alarm, what is the probability that Mary is going to call you? That probability is given as 0.7. So the second term is 7. Now let us go to the third term. Probability of alarm given no burglary, no earthquake. So both these things are no. That means go to false for both these variables. When they are false, the probability of getting alarm is 0.001. So substitute that value. Now you multiply all these values, you will be getting the final answer for your question. That is nothing but the probability that alarm rings, but neither burglary nor an earthquake has occurred, and both Mary and John calls you is nothing but 0.000628. This is the final answer. What is the probability that John calls you? We are not given any information about burglary, earthquake, Mary calls, and so on. What is the probability that John calls you? So if you see this, when John will call you, is it that John will call you only when there is an alarm? No. Sometimes he may call you when there is no alarms also. One may be either to speak to you about some other thing, he will call you, or otherwise there may be a telephone ringing, he will misunderstand that as an alarm and he will call you. Okay, so the false represent two things. So now we are going to answer this question. What is the probability that John calls you? So you have to see this particular table only. John calls you. So now in this table, John is going to call you when there is alarm, that is when alarm is equal to true, as well as when alarm is false, then also he will call you because the probability value for both is given. So now you have to consider these two cases. So probability of John calls is nothing but probability of John calls you given alarm multiplied by probability of an alarm. That means that this is conditional probability. First, the first event is alarm is ringing and he is calling you. So we will say that probability of John calls when there is an alarm multiplied by probability of alarm. Then what is the second thing? Sometimes he may call you when there is no alarm also. So what is the event there? There is no alarm. That is a pre-event, but he is calling you. That is a second subsequent event. So the probability of John calls you when there is no alarm multiplied by probability of not an alarm. So this is when you add these two, you will get what is the probability that John calls you. Okay, here we are adding the terms. We are not multiplying them. We are adding the terms. Now let us understand how to calculate this P of A. So here Probability of John calls given there is an alarm is given here. Okay, so this is nothing but probability of John calls when there is an alarm. This term probability of John calls when there is an alarm is given in this 0.9. But what about this? How to calculate this? P of A. Probability of alarm is not given anywhere directly. Probability of alarm is given based upon many parameters. Now we have to calculate this P of A. So how to calculate P of A? That we will see now. So P of A is nothing but probability of an alarm. It depends upon 4 different cases now, because alarm is depending upon 2 things, burglary and an earthquake. And we have now 4 different combinations. We have to consider all the 4 combinations now. So the first combination is this one. You can see here, what does this indicates? Burglary is true, earthquake is true, and then there is an alarm. Okay, so that is the first term I'm going to consider. Probability of alarm given burglary and then earthquake multiplied by probability of burglary and earthquake. Why I am doing this multiplication? Because this is a conditional probability. The alarm will ring given that there is a burglary and then there is an earthquake. So you should write only the conditional probability here. Okay, so now that is the first term which is related to the first row in this table. And what is the second row in this table? It says that burglary is true, earthquake is false. So what is the probability? That you have to consider now. So probability of alarm given burglary, comma, not E. That means that earthquake is false. This is again conditional probability. So multiply by probability of, what is this? Burglary, comma, not earthquake. So this is corresponding to the second row. Now go to the third row. In the third row, we have burglary as false, but earthquake as true. So you should calculate what is the probability of getting an alarm for this particular row. So probability of alarm given no burglary, but there is an earthquake. And this is a conditional probability. So multiply by the original event, that is nothing but probability of no burglary, comma, earthquake. Now the third row is over. Go to the fourth row. Fourth row corresponds to there is no burglary, no earthquake, but still you are getting an alarm. So probability of getting an alarm given no burglary, no earthquake. Not stands for no. Multiply by conditional probability. So you have to multiply by probability of no burglary, comma, no earthquake. Now let us see this various values. So first is probability of A given B, comma, E. That is nothing but that is here. It is 0.95. Multiply by probability of B, comma, E. What is this probability of B, comma, E? 2 events are happening here. First event is probability of burglary and second event is probability of earthquake. But here, these 2 events are conditionally independent events. We have seen in the probability that when 2 events are conditionally independent, we can write P of A intersection B as P of A multiplied by P of B. Therefore, since these 2 events are conditionally independent, I can write P of B, comma, E as P of B multiplied by P of E. So what is P of B? That is given here, 0.001. So that is the second term. And third term is P of E. It is given as 0.002. So now the first term is written as 0.95 multiplied by 0.001 multiplied by 0.002. Now let us understand the second term. The second term is corresponding to the second row. So take the probability from here, that is 0.94. That is the first value. It's nothing but probability of alarm given B, comma, not E. Now that is clear. What about this probability of B, comma, not E? That is not given directly, but we have to calculate by applying independent events. Since B and E are independent, we will write now as probability of B multiplied by probability of not E. So what is probability of B? That is given as 0.001. So substitute the term directly. But what about probability of not E? It's nothing but probability of not having earthquake. That is not given anywhere. But probability of earthquake is given. That is given as 0.002. Therefore, probability of not earthquake is 1 minus 0.002. So we will have 0.998. That is for this term. Now go to the next term. That is for the third row. Here the probability is 0.29. So you can write the value. And considering the second term, probability of not B, comma, E. Since they are independent events, it's nothing but probability of not B multiplied by probability of not E. Probability of not B is 1 minus 0.001. It's nothing but 0.999. And probability of E is directly given here as 0.002. I can substitute it. Now coming to the fourth term, it's corresponding to the fourth row in this table. It's having the conditional probability value as 0.001. Substitute that. And last term is probability of not B, comma, not E. So here it is 0.001 multiplied by probability of not B is 1 minus 0.001. So it is 0.999. And the second term is probability of not E, that is nothing but 1 minus 0.002, that is 0.998. When you multiply all these things, you will get probability of A. Okay, so now you see we are proceeding with this term. The first term, we know the value. For the second one, P of A, we have calculated this. Similarly, you have to consider the second case. Second case is nothing but probability of John calls when there is no alarm multiplied by probability of not getting an alarm. So probability of John calls when there is no alarm is given here, okay, in this term. Whereas probability of not having alarm is not given anywhere, but you can calculate it by applying this formula, or otherwise there is a simple way. You know that for any event, if probability of alarm is given, you can calculate what is the probability of not having alarm. That is nothing but probability of alarm is given as 0.00252. So probability of not getting alarm is nothing but 1 minus 0.00252. When you do that, you will be directly getting this answer. Since you know P of A, you can calculate P of not A simply by subtracting P of A from 1. So this is the final value of P of not A. Now substitute these values in this equation. You will get the probability that John calls you. So the first term probability John calls when there is an alarm is 0.9 from this table. So multiply that with P of A, which we have calculated, that is 0.00252 plus the second term. Probability of John calls when there is no alarm is given here, 0.05. Multiply that with probability of not A, which you have calculated. So this is the final answer. Okay, so now this is a complex problem, but since the problem is modeled as a Bayesian network, with the help of these conditional tables, we are calculating the probability of various events.